and welcome to Charles' Law. In 1787, Charles related the volume and the absolute temperature of the ideal gases at a constant pressure and the mass in the form of Charles' Law. Charles' Law states that for a fixed mass of a gas, the volume is directly proportional to the absolute temperature at a constant pressure. So we can write this equation as V is directly proportional to T, where V is the volume of a gas and T is the temperature. This equation shows that when the absolute temperature increases, the volume also increases to the same fold. So we can write this equation as V is equal to K into T, where V is the volume of a gas, T is the temperature, and K is constant pressure. Or we can also write this equation as V by T is equal to K constant. Graphical representation of the Charles Law. Graphically, a plot of the volume against the absolute temperature of a gas at a constant pressure is a straight line. As you can see here in a graph, there is a straight line which shows the direct relationship between the volume and the absolute temperature. It means that as the temperature increases, the volume of a gas also increases. Charles' law can also be stated as, for a fixed mass of a gas, the ratio of the volume and the absolute temperature remains constant at a constant pressure. It means that the volume changes with the change in the absolute temperature, but the ratio V by T remains the same. For two states of a gas at a constant pressure, let the volume of a gas is V1 at the absolute temperature T1. Then we can write this as V1 by T1 is equal to K, where V1 is the volume of the gas in state 1, T1 is the temperature, and the K is the constant pressure. If the pressure changes to P2, then the volume will also change to V2, such that the ratio remains the same. So we can write this as V2 by T2 is equal to K, where V2 is the change in the pressure, T2 is the change in the temperature, and the K is the constant pressure. Now comparing these two equations, we can write this as V1 by T1 is equal to V2 by T2. Experimental verification of the Charles Law. Friends, as you can see here in a diagram, we have two cylinders with a movable piston. These cylinders are filled with gas, and here in both cases the pressure R is kept constant. So what happened when there is a low temperature? Friends, let's discuss about it. So at low temperature, the kinetic energy of the molecules decreases. As a result, the number of the collision of the molecules per second with the walls of the container also decreases. So at a constant pressure, the volume must decrease. It shows that at a constant pressure, the volume of a gas is directly proportional to the temperature, or in simple words, we can say that, as you can see here in a diagram, at the low temperature, the volume of a gas is also low. Let's talk about the second case. What happened at high temperature? Friends, as you can see here in a diagram, that when a gas is heated, the kinetic energy of the molecules also increases, which pushes the piston in upward direction. As a result, the volume of a gas also increases. So due to the increase in the volume, the number of the collision per second with the walls of the container does not change with the temperature. So here, the pressure of the gas remains constant. Or simply, we can say that when the temperature is high, the volume of a gas is also high. It means that the volume and the temperature are directly proportional to each other. Like this video and share it with your friends. And don't forget to subscribe my channel Digital Chemistry.